Hey guys, what's up everyone? How are you people doing? All good? Hello everyone. Hi Ashish, how are you doing? Anyone from other class? Hi Pooja, hi Santosh, hi Tarun, hi Debar Pita. What's up people? How are you guys doing? Welcome back to today's session. What's up? All good? Can you guys all see me now? Can you guys all see me and hear me clearly? Yes or no guys? Give me a quick yes in the chat box. All good? Yeah, welcome to today's session. I have to keep my phone over here just so that I can read your chats and stuff. So yeah, it's gonna be a little weird because I have to look down, not much on the camera. Anyways, welcome back to today's session. Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back. So people, can I get a quick yes in the chat box if you guys are all able to hear me and see me clearly? Quick yes in the chat box. Come on, go quickly, quickly. All right. All right. Can you guys all hear me now? Are you guys there? I am not able to read your chats. I don't know what is happening. All right. Okay. One second. All right, people. I'm not able to read your chats. Hopefully, you guys can hear me and see me. I am going to move ahead with the topic then. All right. All good. All right. All right, guys. So, anyways, let me introduce myself. My name is Anoop and a very warm welcome to all of you guys out there. I know this is the first proper live session that we are having, so hopefully you guys will take it a little easy on me. So this is the first session that I'm taking on YouTube as well, I mean live on YouTube. So today we'll be doing the Menti quiz on the chapter electricity. Now we have done a lot of sessions of electricity before this. We have covered pretty much the entire chapter of electricity. So today I'll try to answer all your doubts, and also we'll have a lot of quiz questions. So first thing I want you guys to do is take your pen and paper and be ready, because there'll be a lot of problems that we'll be asking, and I'm going to give you a certain amount of time, but I would also request you guys to keep the Menti slides on. How many of you guys know about Menti? Give me a quick yes. Give me a quick yes in the chat box if you guys know about Menti. Yeah, Menti. You guys know? Yeah. What is OP? All right. Yeah. All right. Yeah. Thanks a lot, people. Thank you. Thank you. Thank you. All good. You guys know about Menti, so I want you guys to, I'll give you the website. It's www.mentimeter.com. So you have to go to that website and keep it ready, because we'll have a quiz on the Mentimeter. So you have to be ready with that as well. So whoever joins, again, you guys know the drill of Menti, so I don't have to explain the rules and regulations. But yeah, the faster you answer, the more points you get. As simple as that. All right, guys, so we'll get started with today's session, people. This is the chapter, the whole chapter quiz. But before we get started, this is the quiz. This is the, the quote for the day, and the quote was this, guys: if people are doubting how far you can go, go so far that you can't hear them anymore. And that is, it's a very deep meaning. It's like, try to be the best version of yourself, so that you're not able to listen to all of that and get to where you really want to. So that's it, fine with you. That is all I have to say. With that said, let us get started with today's session. But before that, one more thing is that in the last session, that is heating effect of electric current, I had given you a homework. This was your homework. 100-watt bulb is operated for 8 hours daily. Find the cost of operating this bulb for 30 days, assuming the cost of electricity is 4 rupees per unit. So this was the question. I'm not going to show you the calculation part, because I'm pretty sure that you guys know the calculation parts. What I'm going to do is that I'm going to write down the formula for you guys. All right, sorry about that. So I'm going to write down the formula and what is the method that you have to solve this. But yes, you can do the calculation later. So the question is this, guys. Okay, one second, people, one second. Apparently, I have not done something that I'm supposed to do. Can you just give me one single second? Sorry about that. I'm supposed to enable editing, and I did not do that. All right, so yeah, 100-watt bulb. So the power is given as 100 watt. They've given you what is the time for how long it operates. It's about 8 hours. They've given you the number of days also. That's 30 days. So you have to calculate how much cost would it be. So first of all, find out what is the total power consumption. So basically that's P, you can just calculate it as it's 100 into the total power consumed is equal to 100 into 8 hours into 30 days. So whatever value you're going to get, that would be basically in terms of kilowatt hour. So you'll get us watt hour. So whatever value you're going to get, that is 8, calculate the value, is how much will it be? 8 into 8, 3, 8 into 60, 8, 3 is 24, 0, 0, 0. So you'll get it as 24,000. Then divided by 1,000, because this is in watt hour. So convert to kilowatt hour. So divided by 1,000, you would get it as 24. Multiply it by 4. you will get the answer. As simple as, okay, so if you multiply it, you'll get the answer. I hope that I have not done any calculation mistake. So it's 100 into 8. The total power consumption is 100 into 8 into 30. You'll get the answer. Divided by 1000, you'll get the answer in kilowatt hour. Then multiply it by 4, multiply it with 4, because that is the amount for per unit. You'll get the answer. As simple as that. Yep. Alright, well, with that said, these are some of the people who gave the answer in the comment section really fast. We have Kavya, Sanju, Shubham, Anika, and we have Parameshwaran as well. Congratulations, keep up the good work, and I hope to see more such answers from you people. Now, if you want your name to be here in the next session, you have to make sure that you answer the question as fast as you can. But for that, you have to be a subscriber. So be subscribe to the channel and make sure that you answer the question really fast. Alright, with that said, guys, let us get into the questions now. Yeah, so soft, no, yeah, if you want me to become all harsh, I can do that. So let's start with the questions right now. I want all of you guys to join the Mentimeter. So this is the this is going to be the Mentimeter, guys. One second. So this is how it's going to be. So please log into www.menti.com. So quickly log into that, and this is the code for today, 4717353. Quickly join, guys. Come on, everyone. I'll give you about 1 minute. That's 30 seconds to 1 minute. Quickly do it. All right. The code is 4717353. Oh, nice. 22 of you guys are here out of 133. About 22. Quickly, come on. Come on. The awesome one. Yeah, thank you, Kushi. Thanks a lot. All right, quickly. Thank you. They were with us. Come on, quickly, guys. Quickly. About 86 of you guys, 90 of you guys. Okay, interesting. It's going to be a very tight competition. Let's see what happens. All right, another. I'll give you another 30 more seconds. Quickly. All those who haven't joined yet, quickly. Come on. Because Manaswati, because I have a lot of regular sessions now, so it collides with my regular sessions. That's why I don't come live as much, because there's a lot of regular sessions I have from 2:30, so that is a problem. Nonetheless, guys, so I'll be starting the quiz in 3, 2, and 1. All 140 of you guys here, awesome. So this is your first question, people. Now you know the drill. You have to answer the question as soon as you can. Here's the question. A current of 4.8 ampere flows in a conductor. The number of electrons that cross any section per second is how much? Your 1 minute time, guys. Is it 10 to the power 19, 2 into 10 to the power of 19, 3 into 10 to the power of 19, or 3.3 into 10 to the power of 19? That is the question. Quickly solve it. Now, if you want, you can use a calculator, because I know you have to do it really fast. So I don't want you guys to do calculation mistake, but I want you guys to get the steps right. That is more important for me. So current of 4.8 amperes flowing through a conductor. The number of electrons that cross any cross section per second is how much? 10 to the power 19, 10 to the power 2 into 10 to the power of 19, 3 into 10 to the power of 19, or 3.3 into 10 to the power of 19. You have 20 more seconds. 154 of you guys have already answered. Quickly, guys, quickly. Come on. 12 more seconds. Oh, let's see. 164 of you guys have answered. All those who haven't answered it, quickly answer the question, guys. Come on. 3, 2, and 1. Here we go. Time is up. Let's see how many of you guys got the right answer. 83 of you guys were able to give the right answer out of 170. Not bad, not a bad start at all. 31 of you guys went with option number 1. 29 of you guys pretty close. All the other options were chosen pretty equally, but the right answer is actually option number C, guys. Now the leaderboard is like this, and I'll show you how to solve this also. This is what the leaderboard looks like right now. We have Enam Abhishek sir fan, awesome, followed by Sanchit, 9th grader. Then we have Abhyudhay, then we have Shubham, then Divakar, thanks a lot, buddy. Arjun, Pritham, Divya, and Casper and Cake. Hats off, people, well done. So how do you solve this particular question? Let me show that to you guys. So after every question, I'll show you what is the method to solve it. I'll not be doing the calculation, because again, it takes a lot of time for you to do the multiplication stuff. We have to do a lot of questions, and I have to solve your doubts as well, so we don't have much time. I'll be just doing the showing the steps. So first of all, current is given as 4.8 ampere. Now here's the thing, guys. The charge on each electron is 3.6 into 10 to the power of minus 19 coulomb. So that is the charge on each, if I'm not wrong, I think that is a value, no, not 3.6, 1.6, sorry, 1.6 into 10 to the power of minus 19 coulomb. That is the charge of each electron. So you have to find out what is the number of electrons passing per second. So what will be the answer? So if you know that basically current is equal to charge per the charge running through, or the rate of flow of charge, that is what is current. So here the if you think about it, you don't know the number of electrons passing through that particular point, so you'll take it as n into 1.6, because that is a charge of 1 electron, into minus 19 divided by the time taken. The time taken is 1 second, so divided by 1, you will get the answer. And the current is 4.8, so if you do it, so you'll get it as n is equal to 1.6 into 10 to the power, sorry, 4.8. Let me just correct that. Sorry people, sorry, I'll make a lot of mistakes like this. Please feel free to correct it. 4.8 divided by 1.6 into 10 to the power of minus 19. So you'll get the answer. If you divide this, you'll get the answer. How many of you guys have done this exactly correct? Give me a quick yes in the chat box. Did you guys do it the exact same way, or you just like to come out A, B, C, or D, like, you know, like Inky, Pinky, Popky? Did you guys do it this way, or did you guys do it? You guys did it the right way, no? Exactly, guys. So just remember this, that the charge of each electron is 1.6 into 10 to the power of minus 19 coulomb. So once you put that value over there, you would be able to get the answer. As simple as that, guys. That is the answer for the first question. So here it is, guys. Moving on to the second question. Back to the Mentimeter. Here we go. Second question. Let's go. What is the second question? Let's see. This is the second question, people. Let's see what is the question. Come on, come on. What is the question? Let's go. Okay. So the question is, get ready. The amount of work done when a charge of 6 coulomb moves across 2 points which have a potential difference of 2 volt between them is what? The question is, what is the amount of work done when charge of 6 coulomb moves across 2 points which have a potential difference of 2 volt between them? Is it 3 joules, 2 by 6 joules, 12 joules, or none of these? Now for this question, I'll give you a hint. Just try to recollect the formula of potential difference. You'll get the answer. Simple as that. Just try to recollect the formula of potential difference. You'll get the answer. As simple as that. Come on, come on, come on, come on. Let me know. Come on. You have another 25 seconds. Do the calculation as far as now. Like I told you, if you want, you could use a calculator, but in your exams, it's not allowed. The reason why I'm asking you to use a calculator is because you have only 1 minute time, and I'm more concerned about you getting the steps right than the calculation right. So calculation, though, you have enough time in your exams to get it right. So here, try to because there's only a little time for you to do the calculation. That's why I'm urging you guys. All right. Anyways, here is the answer. Once again, 104 of you guys gave the right answer this time. Much better than the previous one. Awesomely well done, people. 57 of you guys went with 3 joules. 23 of you guys went with 2 by 6 joules. Luckily, none of you guys chose none of these. That is good. Anyways, here is the leaderboard once again. At the end of that question, we have, unfortunately, no, none of you guys in the leaderboard gave the wrong answers. You have Sanchit still leading, I believe. Yes, but Divakar has moved up to second position. Third is Arjun, fourth is Pritham, fifth is Shubham. Then you have, do you know BTS song Dynamite? Yes, I know. Then we have Savya, Swatam, Abhidya, and also Ishan. Congratulations, keep the good work. Absolutely wonderful. Let's see what happens to the next one. Anyways, this is the answer to this question, guys. The question is this: the amount of work done when a charge of 6 coulomb moves across 2 points which have a potential difference 2 volt between them is what? So the answer to this question is actually pretty simple. If you guys remember the formula which I told you in the regular sessions, if you talk about it, potential difference is equal to work done to move a unit charge. So it is nothing but W by Q. So if you put down the value, so you have, suppose you find out the work done, so work done would be what voltage into the charge. So basically, what is voltage? It's 2 into the charge is nothing but 6, so it's nothing but 12. Nothing but 12. That's all. So that is the answer, guys. 12 joules. That'll be the answer for this question. As simple, guys. Direct answer. There's nothing to do. You don't even need a calculator for this one. It's a direct answer. So well done. Hats off to all those guys who gave the right answer. Moving on to the third question. Let's go. Here's the third question, people. Hope you guys are ready for this one. Here it is. And the question is, okay, why am I showing the leaderboard? Alright, where's the third question? I want to see the third question. Here we go. Okay, wait a second. Now, where's the third question? Wait. Did I skip a question? Oh, this is the third question. Sorry. All right. Yes, let's go. I'm still, finding my way around it. Here's the question. The length and area of cross section of a resistor are doubled. Its resistance will be halved, unchanged, doubled, or quadrupled. The question is, if the length and the area, you're doubling both the length as well as the area of a resistor, what would happen to its overall resistance? Would it be halved? Would it remain unchanged? Would it double, or would it quadruple? 159% of you guys have already answered. All those who haven't answered yet, quickly. And all those who are just joining right now, quickly log into menti.com and put in the code 471735 and 3. And quickly, come on. The length and the area of cross section of a resistor are doubled. Its resistance will become what? Yeah, come on. Come on. Halved, unchanged, doubled, or quadrupled. 18 seconds left. 18 seconds left. 18 seconds. 18 seconds. Another 10 more seconds. 7 and 6 and 5 and 4 and 3 and 2 and 1. Let's go, people. 100 and okay, around 200 of you guys have answered. Let's see who got the right answer among all of those. Okay, here we go. Okay. Interesting. But somehow, by a very slight majority, 69 of you guys gave the right answer. 49 went with halved, 48 of you guys went with double, and 30 of you guys went with quadruple. But the answer to this question would be, guys, it'll remain unchanged. Why so? Let me just show that to you. Coming back to the solving part. So basically, guys, this was the question. So if you remember the formula, resistance is equal to resistivity of the material into the length divided by the cross sections, because it's directly proportional to the length and indirectly proportional to the area of the cross-sectional area. Now, in this case, the resistance or the length is also doubled, the area is also doubled. So what will happen? Both will will get cancelled. So what will happen to the resistance? It will remain the same. It will remain unchanged. There's no change whatsoever because it gets cancelled out. Simple, guys. Simple as that. It's okay. Happens. But yes, guys, remember this formula. It's a very, very important formula. Resistance is equal to resistivity of the material into the length of the conductor divided by the area of the conductor. Remember this formula. It's going to be super, super helpful. All right. Moving on to the fourth question, people. Are you guys able to understand so far? Give me a quick yes in the chat box. Come on. Quickly. I'm going to give you 30 seconds. Quickly. Are you guys able to understand everything? All right, people. All right. Thank you. Hi, Kavya. Welcome. Hi, Sudhu. All right, Sudha. All right. All right, so we'll go to the next question then. All right. So here's the leaderboard. By the way, we have. Okay, I didn't show you the leaderboard at all. Here's the leaderboard, people. It's. Let's see. Anyways, we have Pritham, who's taken the first position, followed by Swatam, then it's Soham, and then you have Clarot, then it's Simran, Sanju, Dishant, Manan, and Namya, and also Vineet. So many physics kings and love people physics. Good to know, guys. Moving on to the next question, people. Here is your next question, the fourth question. Let's go for this. It's let's see, what is the question like? Three resistors, R1, R2, and R3, having value 6 ohms, 12 ohms, and 36 ohms are connected in parallel across a battery of 24 volt. Calculate the equivalent resistance of the combinations and also calculate the current in the circuit. You're supposed to calculate what is the total equivalent resistance and also the total current of the circuit. Your options are: option A is 2.5 ohms and 4.56 amperes, 3.6 ohms and 10 amperes, 3.6 ohms and 6.67 amperes, or to 1.2 ohms and 5.5 amperes. So what is the answer, guys? Come on. Let me know, people. Let me know. Hi, Pratham. What's up? We'll have it soon, Sangeeta. We'll have it soon. We have already started off with the ICC chapters. Also. I had completed torque. Yeah, I completed torque. Now we'll be starting off with machines also. Yeah, come on. Sure. Oh, is it? I'm covering the question. Oh, yeah. How will I? All right, 1 second, guys. 1 second. I don't know what to do. Okay, I'll just move out of the frame for now. I hope you guys can see the question now. I don't know what to do for this one. I'm really sorry, guys. I'm really sorry. Come on. Alright, I'll just move out of the question completely. How do I show this now? This is impossible. This is a conundrum. I didn't know about this. I hope you can see the questions now. Three resistors, R1, R2, and R3 having resistor value 6 ohms, 12 ohms, and 36 ohms are connected in parallel. The voltage or the potential difference is 24 volt. Alright, awesome. Even after covering up the question, I'm really sorry, guys. I'm really sorry that I did not realize it until it was too late. Nonetheless, 121 of you guys still managed to get the right answer. Hats off, people. Superbly well done. So, how do you solve this question? It's a very, very straightforward question. But before that, let's take a look at the leaderboard. This is what the leaderboard looks like at the end of that fourth question. We have any change? Everyone on the leaderboard has given the right answer. That's interesting. Nonetheless, is there going to be a shift? Yes, there is. Pritham still leading, followed by Swatam. Then it's Clarot, Namya, Manan, the physics king, Vineet, Mark. Then it's Ananya, Tanushree, and Akshara. Congratulations, keep up the good work. With that said, let us try solving this question as well quickly. Let me just take you through it again, guys. I'll not be doing the entire calculation because you guys got it right. So, anyways, to find out the equivalent resistance, R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, 1 by R3 for 3, because they are all connected in parallel. So they are all connected in parallel. Yeah, they're all connected in parallel. So find out the value of that. So it will be 1 by 6 plus 1 by 12 plus 1 by 36. So take 36 as the take 36 as the LCM. Find out the value, you'll get the value of R equivalent. So whatever is the value of R equivalent, substitute that value in your Ohm's law wala equation. So V is equal to IR is what is Ohm's law. We know the okay, so you don't know the current. Do we have the current? They've not given you the current. So let's do one thing. We can use this equation. One second. We know the, yeah, we have to find out the total current. So yeah, we know the resistance. So whatever is the R equivalent value, put that over there. So to find out the current, so it will be I is equal to V by R. You're supposed to find out the current, no? Yeah, so whatever is the, so it will be 24 divided by R equivalent. You'll get the answer. Alright guys, sounds good? Yes, people, give me a quick yes in the chat box. Are you guys able to understand? Yeah, all good. Were you guys able to, again guys, I'm not going to show you the calculation because it might take a long time, and on top of that I might make mistakes. So let's avoid that and try to keep it as simple as possible. All good? Alright guys, okay. So that is how you find out the value. Now just take the LCM of this. Whatever is the LCM of that, because it's given as 1 by that of that, reciprocate that to find out R equivalent value, because it's 1 by R equivalent, all right? It's not R equivalent, it will be 1 by R equivalent. So find out R equivalent and then substitute that in the equation of Ohm's law. V is equal to IR, find out the current, as simple as that. Very simple question. Again, you have to do a little bit of calculation and you'll get the answer, all right? So the answer to this question, once again guys, is 3.6 ohms and 6.67 ampere. That'll be the answer, all right? Moving on to the fifth question now. Let's get back. Fifth question. Let's see. What is the fifth question like? Let's go. Halfway through, people. Halfway through. Here's the fifth question. 3 resistors, 3 ohms, each are connected to a battery of 3 volt as shown. Calculate the current drawn from the battery. So there are 3 resistors, each of 3 ohms, 2 are connected in series, 1 is connected in parallel to that, and the voltage is 3 volt, so it's a 3 volt battery. You're supposed to find out what is the current flowing through the circuit. Very, very simple, guys. Is it 5 amperes, 1.5 amperes, 3 amperes, or 1 ampere? What is the answer? Okay, once again, I'm covering the question, I believe. So let me just move back a little, and every time I show the question, I'll just get out of the frame so you guys can see the question. All right? That way, I'll try to make your life easier. Yeah. Come on, come on. You have 45 seconds. All right, this is really funny. All right, come on, guys. All those who have an answer, quickly answer the question. 3 resistors of 3 ohms connected to the battery of a 3 volt. So connected to a 3 volt battery. You're supposed to find out what is the current flowing through the circuit. Quickly do it, guys. Quick. Done. 30 more seconds. Guys, all those who are not in the Menti, quickly join the Menti quiz. Quickly join it. Quickly. Go to the website www.menti.com and enter the code 47 17 35 and 3, and then be a part of the quiz. Quickly. All right, 9 more seconds. I'm going to come back right now. I think that's, yeah. You guys have seen the question. All right, so here we go, guys. Once again, here we go. This is the overall 111 of you guys gave the right answer. Hats off, guys. Superbly well done. 14 of you guys went with option number A, 26 for option B, and 18 for option A as well, option number C as well. However, the right answer to this question is actually 1.5 amperes. I'll tell you how to solve it, but nonetheless, before that, let's take a look at the leaderboard. Let's see if any one of you guys have made a mistake. I don't think so. No, everyone in the leaderboard still going very strong. This time, okay, there's a little difference in the last few, but the first 7 is still the same. Pritham, Swatam, Clarot, Namya, Niveet, Mark, Ananya, Akshara, Pratik, and Tanushree as well. Congratulations, keep up the good work. With that said, let us try to solve this question as well. It's a very straightforward question. So the question is, you're supposed to find out what is the current flowing through the circuit. So first of all, find out the equivalent resistance. So to find out the equivalent resistance, first of all, these two are in series. So add them both up. first of all, find out the equivalent resistance in series. I'll take it as RS for now. So in series, how do you calculate the equivalent resistance? It's the sum of both the resistance. So it's basically 3 plus 3, that gives you 6 ohms. Now that you have made you have found out the equivalent resistance of that, find out the parallel resistance now. So RP, so 1 by RP is equal to 1 by RS plus 1 by R3. I'll take this as R3. So R is basically what we just found right now. So it'll be 1 by 6 plus 1 by 3. Find out, so it'll be into 1, and into 2. So that's 2 divided by 6, 2, 3, 6. So you'll get it as 1 by 3. So RP, you'll get it as 3 ohms, right? You got it as 3 ohms. Now that you found this, put that in the equation of Ohm's law. V is equal to I into R. We know that I value, we have to find out the I value. So voltage is given as 3 ohms. Resistance, we found it as R. So I into 3. So I is equal to, sorry, I think I made mistakes. 1 second, guys, 1 second. All right. So sorry. Yeah, I made a mistake. It's 3 by 2. No, it'll be 3 by 6 because it's 2, right? So 3 by 6. So that'll be 2. 1 by 2, guys. Sorry about that. So it'll be 2. Resistance will be 2. So it'll be 3 divided by 2. That'll give you 1.5. Yeah. Sorry, guys. I did not see this. So it'll be 2 plus 3. That is 3 divided by 6. Not directly 2 by 3. It'll be 1.5 amperes. As simple as that. All right, guys. So that is the answer for this question. Moving on to the next one. Here we go. The next question. What is the question? Okay, sorry. Yeah, I'm supposed to press enter. Every time I keep forgetting it. All right, here's the next one. The 6th question. Let's go, guys. Let's go. Here's the question. The question is, what is it? A torch bulb works with a cell of 2.5 volt and current through is measured to be 500 milliampere. Find the power consumed and the resistance of the bulb. You're supposed to find out what is the power consumed as well as the resistance of the bulb. Remember the formula of power and find out the resistance of the bulb. Using the same, you could use Ohm's law or you could use the power formula itself to find out the resistance. Quickly do it, guys. You have 1 minute, 10 seconds. I'm going to move away from the screen once again so that you guys can see what the question is like. Quickly, guys, come on. Come on, guys, quickly. Let me know what is it. A torch bulb works with a cell of 2.5 volt and the current through it is measured to be 500 milliampere. Find the power consumed and the resistance of the bulb. Quickly. Awesome, guys. Come on. Suddenly, you just have to go to the website www.menti.com and then enter that code that you see on the site 4717353. You'll be a part of the quiz. All right, quickly do that now. Come on. Yeah, you just have to go to Mentimeter and then enter that code. That's it. Is it all right? All right, people. Let's see. Thank you, Deepika. Thank you. Let's go, guys. 15 more seconds. All those who haven't answered it, quickly answer the question. 10 more seconds. 4, 3, 2, and 1. Come back to the slide now. All right, so here we go. This is going to be a big trouble now, going back and forth. Anyways, here is the overall result. 93 of you guys gave the right answer. Well done, people. 27 going with option number B, 23 going with option number C, and 17 for option number D as well. However, the right answer is option number A. Again, to show you the leaderboard, this is what the leaderboard looks like. At the end of that question, we have okay, unfortunately Pradham and Swatam got the wrong answer, so there's going to be a big change in the leaderboard. We have Namya, who's in the first right now, followed by Vineet. Then it's Mark, then it's Akshara, Pritham, Ananya, Shubham, Swatam, Soham, and also Mishra. Congratulations, keep the good work. Unfortunately, Swatam, you were leading all this while. It's okay, no worries. All right, so coming back to the topic, guys. How do we solve this question? So this is the question. A torch bulb works with a cell of 2.5 volt and the current through it is measured as 500 milliampere. Find the power consumed. First of all, guys, if you remember the formula of power is nothing but the voltage into the current flowing through the circuit. So in this case, they've given you the voltage as 2.5 volt, but then the current is given in terms of milliampere. It's given as 500 milliampere. Convert that to ampere first. So divide that by 1000, you'll get a 0.500 or 5 ampere. 0.5 ampere. So that's what you're going to get. Now put in the equation, so power is equal to, so it's given as milliampere. Make sure that all the units are the same, guys. So here it's given in milliampere, so divided by 1000 to convert it to amperes. So it's nothing, milliampere means 10 to the power minus 3. So convert that, you'll get it as 0.5 100 amperes. So it'll be 2.5 into 0.5, you will get the answer of the power. So what was the value that you guys got? 2.5 into 0.5. What is it? Come on, quickly, chat box. Come on, people. Thank you, thank you. All right, Akshat, I can't help it. Sorry. All right, quickly, guys, quickly. What is the answer? 0.5 into 2.5. What did you get? I know. The question is a little difficult. That's why I give you enough time, and that's why I told you if you want, you can use a calculator also. 1.25. All right, you guys, 1.25. Great. Then now to find out the resistance. So resistance is what? If you remember the formula of Ohm's law, V is equal to I into R. So you know the current now. You know the voltage as well. Put it on the equation. Find out the resistance. So resistance is equal to what? Is equal to V by I. So what is that? It's 2.5 divided by the current flowing through the circuit. That'll be 0.5. You'll get the answer. As simple as that. That's all, guys. That's all. That is the answer for this question. As simple as that. So what is 2.5 divided by 0.5? Quickly, people in the chat box. 2.5 divided by 0.5. What is it? 5. Pakka. Pakka. All right, people. Exactly correct. It'll be 5 ohms. That's all, guys. So that is the answer for this question. It'll be option number A, 1.25 watts and 5 ampere. As simple as that. Moving on to the 7th question. Let's go. 7th question. Let's go. Let's take a look at this one. Almost 3/4 of the way through. Here we go. Two lamps are rated 100 watt and 220 volt, and another 200 watt at 220 volt are connected in series and in parallel to the electric main supply of 220 volt. Find the current drawn in each case. So you're supposed to find out what is the current drawn when it's connected in series and when it's connected in parallel. So these are the values. They've given you the power, they've given you the voltage as well. So it's 100 watt at 220 volts, 200 watt at 200 volts. So you're supposed to find out what is the current drawn in parallel and in series. Go for it, guys. I'm again gonna move away so you can read the question. You have 1 minute time. Let's go. Come on. Is it the current in series is 0.30 amperes and in parallel is 1.5 amperes. In series is 0.30 amperes and in parallel it's 1.36 amperes. Is it 2.2 amperes and 2.5 amperes, 0.15 amperes and 2.7 amperes? Quickly, come on, guys, come on. I know. That's why I'm moving away. Okay, the options are also not visible. All right, now I have to completely turn off the cam and then work with this. I hope you can see the option. The first option is 0.30 amperes and 1.5 amperes. Alright, so that is the first option. Really sorry, guys, about this mess. Next time I'll make the window a little smaller so you can see it better. And this is the first one, so yeah, it's a learning curve for me also. 4 more seconds. Let's go, guys. Let's go. Here we go again. Time's up. Here we go, people. Once again, this is what the percentage is like. 50 of you guys went with option number A, 54, very slight majority went with option number B, which was the right answer apparently, and 27 of you guys went with option number C, and 6 of you guys went with option number D. Now for this question, guys, this question might seem like a little a hard one, but it's actually pretty simple. More importantly, it's it's actually basic calculation itself. So they've given you 2 lamps. The ratings of it is first one is 100 watt at 220 volt, and the second one is 200 watts at 220 volt again. So you're supposed to find out what is the resistance. First of all, find out the resistance. Okay, so to find out the current drawn, you can use V is equal to IR wala formula. All right, now so first of all, find out the resistance. How do you find out the resistance in series? Now in this case, they've given you the power, they've given you the voltage. So if you remember the formula, power can also be written as V square by R. V square by R. So what is V square? It is 220 square divided by because you have to find out resistance. So I'll rearrange the equation. Take R to the left hand side and P to the bottom. That'll be 100. So what is 220 square? Quickly, people in the chat box, what is 220 square? Quickly, guys, come on. Come on, guys, come on. Quickly. What is the answer? 220 square. What is it? How much are you going to get if you multiply 220 to 220? Nobody's answering now. Hey, what is happening? Distracted. 48400. All right, 48400 divided by 100. 0 cancelled, so you'll get 448 ohms. So that is the resistance in series, or will for the first one, which is okay. So you found the resistance for the first one, find the resistance like this, find the resistance for the second one as well. So this is P1, I'll take this as R1, V is the same, so I'll keep it as it is. So P2 would be equal to V square by R2 again. So again, R2 would be equal to what? It'll be V square is again 220 volt. Divided by the resistance, the power in the second one is 200 volts, so that's 48400 divided by 220, so 0 gets cancelled. So yes, if I'm not wrong, yeah, 220 volts, so that's 211, 2 2s are 4, 2 4s are 8, 2 8, so that's 248. So 248 divided by 11, what is the answer that you're gonna get? Quickly people, 248 divided by 11, what is it? Quick, 248 divided by 11. So for the second one, it's the same, the voltage is the same, there's no difference in the voltage, but okay, sorry, it's 200, right? 1 second, it's 200, not 220, 200, sorry. So 0 gets cancelled, sorry guys, it's my fault. So it will be okay, calculation mistake guys, I wrote as 220, it should be 200. The power is given as 200, right, for the second one. So if you divide it, you'll get it as 2 2s are 4, 2 4s are 8, 2, so you'll get it as 248 ohms. Now add this up for, if you want to find out in series, R1 plus R2. So what I can do, I'll just erase the values, I'll erase this calculation and write down only the values separately. So you found out R1 and R2 right now. Once again, I know it's a little long, can't help it people, that's how it is, can't help it. So one second. So we have all right, so this is what you got. So R1 you got it as R1 you got it as how much? 484 ohms, and R2 you got it as 248 ohms. Now for series, add them both up. So R1 plus R2, you'll get it in terms of series 484 plus 248. For parallel, it'll be 1 by R1 plus 1 by R2. You'll get the answer as 1 by 484 plus 1 by 248. You'll get the answer. Now that you found this out, then use it to find out the current. So now that you found out the resistance, add them, once you find out the equivalent resistance, then find out the current drawn. So use the formula V is equal to IR, you'll get the answer. All right, people. That's it. That is all. I know it's a little long. It's a little long, but then yeah, that's how you do the problem. Can't help it, guys. There's no way around it. So you have to find it like that. So if you find out the so once you find out this one, use the formula V is equal to IR for the first one. Use the formula for the second one as well. You'll get the answer. Simple as that. All right. Moving on to the next question, guys. Here we go. The seventh question. Sorry. Here's the seventh question. Sorry about this, guys. We had to do it. Here's the next one. Alright, so this is the leaderboard, by the way. Unfortunately, Namya chose the wrong answer for this last question. So I think because of that, her position might change a little. Yes, from first, she's come all the way to 8th position. But nonetheless, we have Akshara in the first right now, followed by Ananya, Swatam, Soham, Saksham, Mishra, Kushagra, Namya, Sinha, and also Divakar. Congratulations, guys. Well done. Moving on to the next question. Here's the 8th one. We have a couple of more questions to go. That's all. Here's the 8th question. Let me know what is the answer for this one. 2 more questions, and then I'll take up your doubts as well. Here's the next one, guys. A bulb is connected across a 12-volt battery. The resistance of the bulb filament is 4 ohms. Calculate the energy transferred in the bulb in 10 minutes. So you're supposed to find out what is the energy transferred in 10 minutes time. They've given you the voltage, they've given you the resistance as well. Find out the energy passing through that or transferred in that bulb in 10 minutes time. Is it 12,500 joules? Is it 26,500 joules? Or 25,000 joules? Or is it 21,600 joules? Let me know what is the answer, guys. I'm going to move away again. Quickly, let me know what is the answer. I'm just going to move ahead. Let me know what is the answer. Come on. Come on. The resistance is given as 4 ohms. The voltage is given at 12 volt. The time taken is also given. You're supposed to find out what is the energy passing through that. So in other words, you have to find out what is the heat energy. Remember the formula of heat energy? H is equal to I square RT. So use that formula. As simple as the case. Let me know. Come on. Quickly, people. 25 seconds left. I want everyone to answer. Quick, guys. Why are you guys not join in the Menti? Quickly join the Menti. No, don't answer in the chat box. Answer in the Menti quiz. Come on, quickly. Another 13 seconds. All those who haven't answered it, quickly answer the question, guys. 10 more seconds. I think I'll move back. You guys can see the options right now. No, the first option is 12,500 joules. All right. I know you guys are not able to read the first option because of me obstructing it. Sorry, people. I'm a big boy now. Anyways, here is the percentage once again. 54 by a very small majority of the class. They gave the right answer. Unfortunately, a lot of you guys chose different answers as well. However, the right answer to this question would be option number D, guys. Why so is because if you remember the formula of to calculate heat energy is nothing but H is equal to, which is heat energy, or we can take it as P also. That is not a problem. Energy. So H is equal to V square RT. Sorry, I square RT. I square RT. So current is you do not know the value of I square. So we'll take 1 second, guys. 1 second. Yeah. Yeah. So no, don't take this one. Don't take this one because there's you're not found out the current. So you can first also you can do this. You can find out the current flowing through the circuit, then find that out. That is also possible. Otherwise, 1 second, guys. 1 second. 1 second, 1 second, 1 second. So you can find out the current flowing through the circuit first because the resistance is given and the voltage is given, and then find out the current flowing through the circuit, and then put in the equation I square RT, or you can sorry guys, yeah, I made a small mistake. It's V square RT, not I square RT. Yeah, sorry people, sorry. Yeah, I'm a little nervous right now. I'm a little nervous. All right, so it's V square RT. Sorry about that. It's V square RT. So V square is given as 12 square into resistance is given as 4. Now time taken is given as 10 minutes. So convert that to seconds first. So 10 into 60 seconds. So 10 minutes into 60 seconds, you'll get the answer. Multiply this, you'll get the answers. 12 square into 4 into 10 into 60. Why 60 is because they've given in minutes. You have to convert it to seconds first. So 1 minute to 60 seconds. So multiply with 60, you'll get the answer. All right. I'm really sorry, guys. I'm a little nervous because again, it's my first live session. So nervousness is getting to me. So anyways, that is the answer for that question. So multiply it, you'll get the answer as 21,600 joules. As simple as that. Moving on to the next question, the 9th question, people. By the way, before that, here's the leaderboard once again. Akshara unfortunately chose the wrong answer for this question. So I think Akshara is going to go down for this one. Yes, she is. She's going to come back from first all the way to the last. Soham got to the first, followed by Swatam, back to the top again. Followed by Mishra, then it's Saksham, then Kushagra, Sinha, Namya, Dude Perfect, Divakar, and Akshara. Congratulations, keep up the good work. Moving on to the next question. Here's the 9th question, guys. Let me know what is the answer for this one. We're almost done. 2 more questions and we're done, alright? So here's the next one. Okay, since 45 minutes we've been doing only quiz right now. That's a lot of time. Alright. Okay, 1 second, guys. 1 second, I have some kind of technical issues. 1 second. Okay, 1 second. All right, hold on. So hold on for 1 second, guys. Hold on for 1 second. I don't know what is happening. All right, let me just close this tab. Maybe it's because of this. Yeah. All right. So let me know, guys. 1 second. Let me just refresh the page. Let me just reload this page. Hold on for 1 second, guys. Hold on for 1 second. All right, yes, sorry about that. I know there was some technical issue. I had opened it in another slide, so sorry about that. Okay, so yes, let me know what is the answer, guys. Let me know what is the answer for this one. I think I have to press F5 for this. Yeah, no. All right, let me know what is the answer. All right, let me know what is the answer, guys. Come on, quickly, let me know what is the answer for this question. Okay, let's just keep it like that itself. So yeah, starting right now. Let's go. Let's go. Sorry about that, guys. Sorry, I'm trying to figure it out. All right. Let me know what is the answer. Let's go. A lamp rated 6 volt and electric iron rated 800 volt are used for 6 hours every day. Calculate the energy, total energy consumed in 30 days. Is it 154.8 kilowatt, or 176 kilowatt, or 168 kilowatt, or 146.8 kilowatt? Quickly, let me know what is the answer, guys. Previous question, 1 second, guys. Let me just check that as well. Quickly, let me know what is the answer for this one. Come on. Guys, once again, I made a mistake in the previous question. It's I square RT itself. I made a mistake again. Sorry about that. So yes, anyways, let me know what is the answer for this one. Let me correct that again, guys. Let me know what is the answer for this one. Come on. 1 minute left. Let me know the answer for this one. Come on. Yeah, I'll check the formula again. I'm really sorry, guys. The nervousness is getting to me. Sorry about that. Sorry about that. I'll correct that, guys. 1 second. I made a mistake in the last question, people. Let me just correct that for you guys. Anyways, 30 seconds left. Quickly, let me know what is the answer, guys. Quick, come on. Let me know what is the answer. 18 seconds left. 8 8 more seconds, 8 more seconds. Quickly, let me know what is the answer. 5 more seconds. 3, 2, 1, and we're done, guys. Here we go. I'm really sorry about the previous question, guys. I unfortunately made a mistake. Yeah, I wrote the formula correct first, and then I again wrote the wrong formula. Anyways, this is the answer, guys. Well done, people. Well done. Absolutely correct. The right answer is option number A. Just to let me know, before we solve this question, let me just go back to that question and solve this. I'm really sorry about this, guys. It's I square RT. I'm really sorry about that. I wrote the wrong formula. Again, first I wrote the right formula, and then again wrote the wrong formula. So anyways, for this one, first of all, find out the current. So V is equal to IR. Use the formula for that. I is equal to V by R. So find out the current flowing through the circuit. Then substitute in this equation, that is I square RT. You'll get the answer. As simple as that. Alright. I'm really sorry, guys. Again, like nervousness. All right, hey, here we go. Anyways, moving on to the ninth question. So this is the question. The lamp rated 60 volt and electric iron rated as 800 watt are used 6 hours every day. Calculate the total energy consumed in 30 days. So for this one, find out the total power consumption, that is 60 into 6 hours into, yeah, so you can keep it as into 30. So that will be the answer for the first one. So P1, find that out, 60 into 6 into 3. So find out the answer for the P2. It will be again 800 into 6 hours into 30 days. So add them both up, you'll get the total energy consumed. That's it, as simple as that is. So you'll get it in kilowatt hour. So you can you'll get it as watt hour divided by 1000. You'll get it in kilowatt hour. Or what you can do is that divide this itself by 1000 in the start. So 60 watt, convert that to kilowatt in the start itself divided by 1000. Then put it in the equation. That will also work. Or you can find it like this and sum them both up. You'll get the answer, but you'll get it in watt hour. So convert that to kilowatt hour by dividing by 1000. Don't forget that. All right. Moving on to the last question is the last question for the day. Let's do this. Once again, the last question is, let's do this one. All right. Here's the last one, guys. Last question. All right. Here is the last question for the day. Okay, wait. I'm going back and forth. Sorry about that. Once again, like I told you, this is the first session, so I'm just getting used to all of this. Everything is new to me as well, so all that nervousness is getting to me. All right, last question. Let's go. The last question. Let's do this, and then let's call it a day. Come on. Here's the last one, guys. The question is: an electric heater of power rating of 500 watt operates 4 hours per day. What is the cost of electricity to run it for 30 days at a rate of 3.50 rupees per kilowatt hour? You're supposed to find out what is the total cost. They've given you the power. They've given you the number of hours it operates, the number of days it operates. You're supposed to find out what is the cost, the total cost of it would be like 210 rupees, 120 rupees, 250 rupees, or 300 rupees. Let me know what is the answer. Come on, quickly. Quickly, let me know what is the answer, guys. 1 minute left. All those who have an answer, quickly answer the question. 15 more seconds. 15 more seconds. Quickly, people. Quickly. The last question. An electric heater of power rating of 500 watt operates 4 hours per day. What is the cost of electricity to run it for 30 days at a rate of 3.50 per kilowatt? All right. Let me know what is the answer. 33 seconds left. 25 seconds left. 20 more seconds. Come on, quickly, guys, quickly. All those who haven't answered yet, quickly answer the question. This is the last one. Last one. 10 more seconds. 7, 6, 5, 4, 3, 2, 1. And we're done, people. Here we're done. So the answer for this question would be option number, let's take a look. So which is it? It's okay. Majority figures went with option number A, that is 210 rupees. And apparently that is also the right answer. To calculate that, again, guys, how do you do this is, first of all, again, using the same, you have to do the same exact thing. First of all, find out the total power consumption. So that's 500 into 4 days into 30, 4 hours a day into 30 days. So whatever value you get, you will get it as 5, 4, 20 into 3 is 2, 3 is 8. So 8,000 if I'm not wrong. 5 3s 5. Oh, so sorry. It'll be, how much will be? Once again, guys. Once again. So calculate, guys. What will be the answer that you're gonna get? Sorry about that. 5 4 20. So 20 00 into 30. So that's 3 to 6. Sorry. Yeah. Okay. You'll get it as 60,000. Everyone got 60,000? Yeah, 60,000 you got. So that is the total power consumption. That is in watt hour. That's in watt hour. Divided by 1000, you'll get it as kilowatt hour. Divided by 1000, you'll get it as how much? 60 kilowatt hour. So that is what you're gonna get in terms of kilowatt hour. Now that you found this out, find the cost of this. So multiply this 60 into 3.50. How much are you gonna get? 60 into 3.50. What is your? Come on, quickly. 50 into 3.50. What is the value that you're gonna get? Come on, come on, come on. Quickly, guys. 200, 210 itself. Everyone got the same. That's all, guys. So the right answer would be 210 rupees. As simple as that. So find out the value. What you see, always make sure that you check the units. Once you find out the units, it'll be as simple as that, guys. So that is it, people. That is it from my side. I mean, that is the Menti quiz. We'll also try to solve some questions of some doubts as well. So here is the final leaderboard of the day of the session. So let's see who's the winner. I'm guessing it's Soham, but let's see if there's going to be any change at all. Unfortunately not. Soham is the winner for today. Congratulations, Soham. Well done. Followed by Swatam, then it's Kushagra, and then we have Dude Perfect, then it's Akshara, Simran, Divakar, Saksham, Harshit, and also Mishra. Congratulations, keep the good work. Absolutely wonderful. Once again, I'm sorry for the mistakes that I made again. So now, guys, now is the time for you to ask your questions. So let me know what are your doubts that you have. So these are some of the questions that were asked to me. The first question was, what is the difference between potential and potential difference? And then what is the difference between resistance and resistivity? So the answer for this question is potential is nothing but the amount of work done to move a unit charge from a certain point, from infinity to a certain point, and potential difference is basically the amount of work done on two different charges to bring it from infinity to see, for example, I give this example. For example, if you want to lift something, let's say that you want to lift up this mouse. All right, to lift this up till here, you need to do some work. To lift this up till here, you need to do some more work. So what is the difference in work done? That is what is potential difference. So in this case, the difference in work done to move a unit charge from infinity to a certain point, that difference in work is what is called as potential difference. All right. Then to answer the second question, resistance and resistivity. Resistance is nothing but the obstruction offered by the circuit, which depends on the area. It depends on the resistivity of the conductor, the area, the cross-sectional area, as well as the length of the conductor. But resistivity is nothing but the property of the material. That is how much resistance is the material offering. So for example, if you talk about insulators, they'll have very high resistivity compared to a very good conductor, which will have very less resistivity. So it's a property of the material. Resistance depends on three factors. That is the obstruction offered. So it depends on the resistivity, the length of the conductor, as well as the area of the conductor. Resistivity is the property of the material. As simple as that. Now, guys, you guys can ask me whatever doubts you have in the comment section. Pretty much all the doubts were the same. So whatever doubts you have, you guys can ask me in the comment section right now. Come on, quickly, guys, quickly. Quickly, guys, quickly, let me know what are your doubts so that we can call it a day. So now ask your doubts. Yeah, ask your doubts. Ask your doubts right now. This is the time for you to ask your doubts. All this while we were doing the quiz. So we're done with the quiz now. You can ask me your doubts, right? Come on, quickly, guys. Any doubts? All right. What is the next chapter after electricity? I think we'll move with. I think we'll be going with magnetic effects. Most probably we'll be going with magnetic effect of electric current. All right. We'll be doing that. All right. Why didn't we use I is equal to P by B? Yeah, we could use that also. I told you there are two ways to do it. Either you can use power wala formula, I square R, or you can use Ohm's law. Both of those are correct. Both of those are correct. Absolutely correct. All right. Either of those are correct. All right. So why we connect ammeter in series and voltmeter in parallel? The reason is that an ammeter has very less resistance, whereas voltmeter has very high resistance. You know that in a parallel resistance, if you talk about in parallel connection, the voltage remains constant, whereas the current is different. Whereas in series connection, the current is constant, whereas voltage is different. So here, what is happening is that because the resistance is more in the voltmeter, it might affect it. So that is why we connected in parallel, so that the voltage across the circuit is not affected. Whereas if you talk about in ammeter, the resistance is very minimum. That is why we connected in series. All right, that is why. Any other questions, guys? Any other doubts? Like I told you, Arun, we can either use that. We can either use P is equal to P is equal to I square R, or you can also use V is equal to IR. Both the formulas are correct. All right. Anything else, guys? Yeah. Any other doubts? Any other doubts, guys? Any other doubts? Potential difference in potential. Again, now potential is nothing but the amount of work done to move a unit charge from infinity to a certain point. Potential difference is the difference in work done on moving a unit charge from infinity to two different points. So you can take two different charges, one to, like, for example, you want to bring, so imagine, I'll try to draw it out so that you understand it. So imagine this is a unit charge. One second, let me take a different color. So this is a unit charge. If I want to bring it to from infinity to a point, that is potential. The work done is potential. Let's say I want to bring it, I'm bringing it to another point. So one I'm bringing it over here, another one I'm bringing it over here. What is the difference in work done? That is what is called as potential difference. All right. It's pretty much the same now. All right. Anything else? Anything else, guys? Anything else? Anything else? The same question. I hope I've answered your question. So why resistance 20 ohms is stretched that its radius decreases by 10%. And if the resistance is, please answer this question. All right. 1 second. Okay. A wire of resistance 20 ohm is stretched so its radius decreases by 10%. All right. Okay. Find its resistance. Use the formula. Use the formula. Resistance is equal to the resistivity of the material divided into the length of the conductor divided by the area of the conductor. So they are decreasing the radius. They're decreasing the radius, right? They're decreasing the radius. So the area of the decrease the area. So divided by 10, divided by 10. So area divided by 10%, you'll get the answer. Simple as that. All right. So divide the area by 10. That's it. So decrease the area by 10%. That's all. All right. Anything else, guys? Anything else? Anything else? What is a galvanometer? Galvanometer is a device that is used to measure the small amount of current. A small amount of current. But when the current is small passing through the conductor, then we use a galvanometer to measure it. All right. Anything else, guys? Anything else? What is the difference between power and energy? Power is nothing but the rate of doing work. The rate of doing work is what is called as power. Energy is nothing but the capacity to do work. So whenever you're doing some work, the capacity, like the food that you eat, gives you energy. What is that? The capacity for you to do work, to run or to jump or to do any kind of task. That is energy. The capacity to do work. Power is the rate of doing work. Work by time is what is power. All right. The rate of doing work is power. And all right. Anything else, guys? Anything else? Is that it? All I see is Binod. All right, it is. Again, anything else? Anything else? That's it. All right, people. All right, then. If that is it, then thank you for joining today's session, people. Let's call it a day for now. Thank you for joining. I hope I answered majority of your doubts. If I did not answer any doubts, let me know in the comment section below. I'll try to answer those doubts as well. Once again, thank you for joining. Thank you for being patient. I'll see you all in the next one. Take care of yourself. Stay safe. Bye, bye, people. Thank you for joining. See you all in the next one, guys. Bye, bye. Take care. Bye, bye, guys. Thank you. Take care.